So going back to this one, I don't carry my subscripts over to the other side unless it is part of a polyatomic ion. So again, just quickly, since that cut off and I'll have a second video here. If I'm doing a single displacement, I've got an element and a compound. My element, I look at this to see if it's a metal or a non-metal or what kind of charge it would have in a compound. Sodium would have a positive charge, so it's got to change places with the positively charged element in the compound. And this is what we're going to get. Remember, don't carry the subscript over unless it's part of a polyatomic ion. You need to see and make neutral compounds on both sides. And again, of course, you'd balance this. Now let's look at the anionic one. On the anionic, this is typically going to be where you're going to have some kind of a diatomic molecule. So let's say that we have chlorine, and we react it with sodium fluoride, for example. Now if I'm looking at this, I can see that chlorine is a nonmetal, so it's going to have a negative charge when it's in a compound. So that means that it needs to change places with the negatively charged element that's in the compound. In this case, it would be the fluorine. So that means the fluorine will come out and be by itself. It is diatomic. And the sodium is going to pick up the chlorine. Again, I'm not carrying the subscript over here because this does not need the 2 to make that a balanced formula. So just be careful when you do single displacement reactions. You don't want to have 2 metals together in your product, and you don't want to have 2 nonmetals together in the product. The next type of reaction is called a double displacement or replacement. Sometimes it's also called a metathesis reaction. These are a little bit easier because you're going to have a compound reacting with another compound, and you're going to produce 2 new compounds. What's easy about these, let's say that we have sodium hydroxide and hydrochloric acid as our initial compounds. Then basically, whatever are the positively charged elements, in this case, the sodiums and the hydrogens, they're simply going to change places with each other. So my hydrogen is going to go over here with the OH. If you rearrange that, that would be water. And my sodium is going to come over here with the chlorine. So you don't have to go to the trouble of figuring out which things change places, because it's the 2 positively charged things, or if you're more of a pessimist, you could do the 2 negatively charged things. It doesn't matter. So again, if we had something like aluminum chloride reacting with iron 2 bromide or something like this, then the iron and the aluminums are what's changing place. So the iron's going to come over here, be with the chlorine. The trick on this one, since this iron is +2, then this iron should stay +2 unless you're told otherwise, which means that I'm going to have to put some different subscripts on this side for the different nonmetals. My aluminum, remember, is always +3, so it's going to go with the bromine, so it's going to need a 3. So just if you have something that has a particular charge, like in this case, if I say that's iron 2 bromide, then this iron on the product side should also be iron 2, unless you're told otherwise. And then, of course, lastly are our combustion reactions. So remember, this is going to be taking an organic compound. Now, so far, we've looked at organic compounds that only contain carbon and hydrogen, but they could also contain oxygen, nitrogen, phosphorus, sulfur. So it just depends. But for simplicity's sake, we'll probably typically have either carbon, hydrogen, or maybe carbon, hydrogen with some oxygen. Okay. You're going to react this with oxygen, and you're going to always form carbon dioxide and water. And then we balance those. So let's look at a couple of these and see if we can classify them by the 5 types of reactions we just did. So if we look at this first one, we're starting off with 1 compound. We're making 2 simpler compounds. So this would be a decomposition reaction. So I'm breaking it down into something simpler. On this one, I have 1 compound and another compound. Basically what's happened is the sodium and the hydrogens have changed places. I get 2 new compounds. So that's going to be a double replacement reaction. I'm going to abbreviate there. On number 3, I have a single element and a compound, and I make a new compound and a single element. So the magnesium changed places with the hydrogen. Hydrogen came out to be by itself, and remember, when it's by itself, it's diatomic. So this one is a single replacement. Since the hydrogen here has a positive charge, magnesium has a positive charge, this one would be a cationic single replacement because what's changing places are the positive ions. If we look at number 4, we start off with 2 simple substances and make 1 complex compound. So this will be a synthesis reaction. On number 5, we have a single element compound, new single element. Aluminum is a metal, changing places with this metal. So this is a single replacement. And since aluminum is a metal, which has a positive charge, it would be a cationic single replacement. Number 6, we have 2 simple substances making a complex one, so that will be a synthesis reaction. Number 7, we have a compound making 2 simpler, so that would be a decomposition. On this one, we have a compound and a diatomic molecule making a new compound and a new diatomic molecule. So I want to look at this. This is a nonmetal. It's changing places with the nonmetal here. Again, it's single replacement, but it's going to be anionic because my fluorine and my chlorines are negative ions. Number 9, compound, make a new compound. My potassium changes places with the silver. So this would be a double replacement. And then this last one would be a synthesis. And then there's a whole nother section on the next slide. So you can try some of these. And again, if you have questions, you can just email me. The last thing in this PowerPoint is looking at predicting products. So what they're going to do is give you your starting materials, your reactant, and you're going to be trying to figure out what your products would be. Now these are typically going to be either single replacement reactions or double replacement reactions because synthesis and decomposition reactions are a little bit more complex in how things break apart. So let's look at number 1. I recommend that you write out in words what you're going to form, and then the rest is going back and working on writing your formulas for your compounds. So here we have magnesium bromide and chlorine. Chlorine is a nonmetal, so it's got to change the places with the bromine. So on this side, I'm going to get the magnesium with the chlorine, so it's going to be a magnesium chloride since it's in the compound. And then bromine will come out and be by itself. So if I wanted to complete this out, I would have my magnesium. Magnesium always has a +2 charge. It's in the second column on your periodic table. Bromine has a -1 charge. It's a halogen that's in that 7. So I'd have to put a 2 here to balance that off so that I have +2 for the bromine. -1 times 2 gives me -2 for the bromine on this side. Chlorine, when it's by itself, remember, is diatomic. Then on this side, we have our magnesium. Magnesium, again, has a +2 charge. Chlorine, a -1 charge. So I'd have to have a 2 here. Bromine, when it's by itself, has a 2, it's diatomic. This one's kind of nice because once I write it, you can see that it's already balanced. So if it's already balanced, you would just put 1s in our coefficient spots. I look at the second one, we have aluminum by itself. We have iron 3. That tells me that the iron has a +3 charge. Oxide is a -2. So if that's -3 and that's if this is +3 and that's -2, then I would need 2 for the iron and 3 for the oxygen. So +3 times 2 gives me +6.